my name is Annie Beckett and I'm from Southern Connecticut State University. Unfortunately, my actual poster is still locked in my university's lab and I'm unable to access it. So I'm going to do my best to present this way, and the poster should be available online. So my poster is on the Diels-Alder reaction of cyclic isoimidium salt dienophiles. Just in case you're not familiar with the Diels-Alder reaction, it consists of a diene with 2 conjugated pi bonds and a dienophile that has at least 1 pi bond. These come together to form a new 6-membered ring. One of the reasons this reaction is so important in chemistry is it is stereospecific with respect to both the diene and the dienophile. This is especially important in natural products chemistry when you need to be able to predict your product's stereoselectivity really, really well. So, one thing that has been a problem with the Diels-Alder reaction is it often requires catalysts or very high temperatures to work, and sometimes it's reversible. So we need to come up with some different dienes and dienophiles that are maybe going to work a little bit better, or room temperature without a catalyst. That's where the cyclic isoimidium salt comes in. This is the general structure of a cyclic isoimidium salt. The R group does need to be symmetrical. So like 2 ethyls or 2 benzyls, it can't be a benzyl and an ethyl. So this salt has proven before to be a very, very good dienophile. It's pretty active and it has a really high regiospecificity. So I decided to expand the scope of that reaction a little bit. The first thing I did was make a large batch of this salt using diethylamine to make an amic acid precursor. So I started with maleic anhydride. This reaction is also on my poster, by the way. And then take diethylamine to make the amic acid. This gave me a little bit of trouble because it had a tendency to turn into an amine salt, but eventually it did happen. And then to go on to the reaction for the salt, treat it with HBF4, and you have your salt. I had some trouble with this reaction at first, but eventually it ended up working pretty well, and I tested a panel of standard dienes with it. Isoprene, cyclohexadiene, some Danishevsky type dienes. I think the isoprene one is on my poster along with the mass spec. So that worked very well to form 1 cycloaddict. Like I said, this is a highly regiospecific reaction. One thing that I also explored is making different isoimidium salt substrates. So I did this reaction, but with dibenzylamine. That actually worked a lot better than I was expecting it to. I got over a 90% yield the first time I did it, so it was pretty awesome. Unfortunately, due to the COVID-19 pandemic, I have been unable to characterize this step of the reaction. This one worked well, and I got an NMR and verified this is my product, but this one has not been characterized yet. But when I get back into the lab, I hope to do that. And then test this benzene cyclic isoimidium salt against a panel of standard dienes. So, for the one using diethylamine, like I said, that one's been pretty successful, but I'm thinking of maybe trying some different dienes like pyrrole. Research has suggested that could work pretty well, or maybe even varying the salt again for different maleic anhydride derivatives. Like I said, this research is important in natural products chemistry when you really want to be able to control stereochemistry. And it's also important because this cyclic isoimidium salt will work at room temperature. It doesn't require heating at all, and it doesn't need a catalyst, which is pretty important when you want to scale a reaction up and you don't want to use an expensive catalyst and it might be unsafe to heat something. So this could hopefully lead in the future to new synthetic routes for old natural products, or even discovering new natural products. Thank you for listening.